I'm going to show you a quick way to make your metal materials look 1,000 times better in Blender. We're going to add anisotropy here. So what that is when the light hits the metal, and depending on what angle it hits the metal at, the light behaves in a different way. Essentially, because this material is machined through turning, as you get the drill bit, the tool that goes around here, it creates these grooves in the metal, which essentially creates, whenever the light hits here, it'll bounce back straight towards the camera, but whenever it hits, say, somewhere else, like around here where it's a bit darker, it'll get reflected in different directions, and that's why you get these sort of highlights around here. So, here's the material setup. It's pretty simple in terms of, compared to most Blender material setups, it's actually not that bad. I'm going to show you how to do it, like all the way through, and I'm going to show you how to tune it and that kind of thing to tweak it to your liking. And of course, I've got some good reference images up here so you can see what I'm talking about. So you see here on like the bottom of a pot or a pan, you can see these little highlights, and you can see the little grooves around the side of the metal. It's very pronounced here. This is like quite pronounced here. And there's some other just in Blender references of what the material is going to look like, and there's one kind of similar to ours. So when you create a new material, this is what you get, right? Just the base principled BSDF node. What we're going to do, metallic to 1 because it's a metal material, and then we're going to take the roughness down to about 0.25-ish. That is about what we're looking for. So the first effect we're going to do is the highlights here. That's really easy to do. Shift A, I'm going to get a tangent node, make sure it's set to Z here. Attach tangent to tangent, and then crank the anisotropic value up to about 0.8. Kind of wherever you want, but the higher you crank it, the stronger it is, right? So that's the highlights. Basically, the way it works is it's taking this Z vector here from the object space and using that to sort of turn the grooves in the metal around, which creates these highlights. And it's in object space, so if you rotate the object, it'll stick with it because the object's new Z vector is this way. Cool. So the next effect we're going to do is we're going to add these little grooves, which essentially we're going to use some noise and some gradient textures to play with the roughness on a kind of procedural basis. So the first thing we're going to do, we're going to add a gradient texture. We're going to create this sort of the effect on the top here. So we're going to take this gradient texture. We're then going to click on it. We're going to hit Control T. If you have the Node Wrangler add-on installed, you can do that. If you don't, go get it. It's really useful. But we're just adding a texture coordinate and a mapping node. We're going to take the object thing from here, plug it into vector, and then set this to spherical. So, and then you can just, if you hit Control Shift and left click, if you have Node Wrangler add-on enabled, it'll switch it to surface, so you can effectively preview it as well here. So the next thing we're going to do, we're going to get a ramp node, which we'll use later on. We're not going to touch this for now, we're just going to put it in between. So, what we're trying to do here is effectively, I'll just kind of use this to illustrate it. We're trying to make a sphere in here that kind of contains the metal part, and then we kind of squish it and stretch it so that it's sort of the same shape as it. But that sounds really weird, but I'll show you how it kind of works. What we're trying to do here, if we play with these scale values, you can see it kind of starts to change the colours of the different surfaces. And if we set this to about 4 or something like that, if you see what it's doing here, it's sort of as if we're creating, again I'll bring that back, as if we're creating a sphere here that kind of contains it like that, right? So the reason we're doing that is because we're using the radius of this sphere, the kind of stretched radius of this sphere, and we're going to plug this into a noise texture, or not a normal texture, a noise texture. There we go. So if we put that in factor, actually we're going to take this color ramp, we put that in the wrong place, we're going to put this straight into vector, and then we're going to put this up here, so we can adjust these and make it a bit more contrasty so we can see what we're doing, right? So if we now take this noise texture and we crank the detail up and the roughness up, and then we can play with the scale and that kind of thing, you see how we've got these sort of rings now because we're effectively using the radius of the circle as the basis. We're sort of creating like the inside of an onion, essentially, is what we're trying to make here. So we've got this now. What we're going to do, plug this into roughness, put this back in here, organize it a little better. And this is way too extreme. Some parts have no roughness, some parts have max roughness, so all we need to do is mess with these here. I'd guess about there is about good. And then for this one, bring it down a bit there. So have them close to each other, but not too close that you can't see any details. This is sort of like tune it to your personal preference at this point. What kind of level of detail do you want? And you can also sort of reduce the contrast by bringing these down a little bit. And then if you scale up, you see here we're starting to get there. I'm actually going to pull this up a bit further so you can hopefully see it a bit better. Not really. There's a lot of fine tuning that needs to go on here. So we take this, bring this down. There we go. That's probably a bit extreme. That's probably a bit more than what you would see in reality. There we go. So I've settled on these values here, and for this left node we've got this hex, and this one we've got this hex here. So you can copy those in if you want, and then just kind of tune it a little bit to whatever you feel is best. So we can technically just use this, but the only issue is because we're using the sphere's radius. If you can imagine, there's a kind of vector going up here, but there's also ones coming out here, and because this is a mesh that's got technically still flat surfaces, if we shade flat, you can see these are sort of flat. You can kind of see here, despite the subdivision. We've ended up with, if we let it render, yeah, we've ended up with these here. So effectively this is staring straight into the radius of the circle, and it's sort of creating these extra turn effects up here. So there's a way to get rid of that. What we're going to do is we're going to use a different gradient texture on the sides to the one we're using on the top. So if we take this, copy it up here and turn this to linear, get a new mapping node, and we can hook it up to the same object, that's not a big deal. Crank that up here. And then we're going to get a color ramp. Oh, actually, no, we're not going to color ramp. We're going to, for now, just put that in there. So you can see it starts from the 0, 0 point of the object space, so the object's kind of origin, and creates this gradient, but it's going in this direction. So what we're going to do is we're going to rotate it around the y-axis here. I've just plugged this in wrong. We're going to plug this not into location, we're going to plug it into vector, and then we're going to rotate it around the y-axis here by 90 degrees. So it's now facing this way, right? Then what we can do, scale it along the z-axis here. We can kind of pick what axis it is. You can scale it along here, and then you adjust its position like that until the dark bit's sort of on the bottom. There. Okay. So now what we can do is we get another noise texture. And we've got the same sort of deal going on here, so you can crank up detail and roughness and then play with the scale to whatever you want. And put this into here and then plug that back in there. Right. So it's now using this, which means there's no kind of radial effect on the top here, because it's slicing it into horizontal layers like this. So to fix that, we're going to use a combination of both of these different effects. So we're going to go into the mix node. We're going to plug these two in here, and then plug that in there. And now it kind of blends between the two of them. But what we wanted to do is we wanted to use the rotational one, the one from the spherical one on the top, and use the linear one on the sides. So we need a way to differentiate between the top face and the sides. So what we're going to do is we're going to go and get vector math, and we're going to switch this to a dot product, or it's not face forward, dot product. And we're going to put this, we're going to make a vector here that is 0, 0, 1, so it's a unit vector on the z-axis, or z-axis. I keep flipping between saying z and z, I don't know why. And I'm going to plug that in here. Actually, we're going to keep this at the top. Just move everything around to keep everything organised. And then we are going to go into geometry and get the normal vector. So this is essentially a dot product between the face normal and the unit z vector, right? So if we plug this in here, you can see that it's 1 here, so that shows up as white, and this is kind of 0 here, which shows up as black. But the thing is, it's -1 here, because what the dot product does is it effectively compares how alike or how closely aligned two vectors are, and in this case they're both unit vectors, so it is basically just based on the angle between them. So they're perfectly aligned on the top face, they're 90 degrees apart, so imagine the vector here and the vector here is 90 degrees apart on this face, but they're 180 degrees apart here, which means the dot product evaluates to -1. So if we take the absolute value, plug that in there, this just becomes 1 as well. So now we take this, plug this into the factor, bring it all together, and there you go. So we're now using purely the linear one on this side, so you can adjust this up here. There we go. I've also just noticed I've kind of have to adjust this a little bit. There we go. Just so it covers the entire thing. So yeah, we've got this here, and it's using purely the radial one on the top. So now we can adjust the radial one on the top, and it won't affect the one on the side here. And there we go. That is our entire material setup. So now, if we just organize everything, and I'm going to adjust this a little bit. I was testing this before, and I know that this is about a good angle. And if we just bring the camera in, F12, let it render, and there we go. So you see we've got this sort of ring effect going on here from the machining. We've got the anisotropy, and you can see compared to something like this, it's pretty close. It's pretty good. There's a lot of other things you can do. You can add this sort of different. I'll scale this up a bit. You can add. You see it's got these little kind of spots here. You can combine some more noise nodes in there to try and get that effect if you like. But personally, I think this is more realistic, and that's a bit more kind of just artistic liberty. Because if you see here, you can see all the little rings, and they're all quite consistent.